So today we kind of getting out of the SCA stuff and we going, we still in numbers and thing, but we gain a little bit out of the SCA stuff today, and we are going a little further ahead into the magic of numbers, and we're going to be talking about the topic of indices. So what do you know indices to be, or indices? Where's this thing?
When I have like a number to the power of the next one.
So generally we know to the power of, right? What does that mean though? Like what you're talking about, like let me just say I have 2 to the power of 3. What does that mean?
It's multiplied by itself 3 times.
Right, so 2 is being multiplied by itself 3 times. Right? So that is one thing. So if I have 2 to the power of 5, that means that 2 is being what?
Multiplied by itself 5 times.
Very good. What if I have 2 to the power of 3 multiplied by 2 to the power of 5? What will that be? I hope you're writing as we go on, right?
And for that kind of multiplication, we just add the indices.
Yes, but why? Can you prove why?
You will get the same answer?
Yeah, but can you prove why you add the indices?
I guess not.
No, all you need to do is easy to prove it. You just take 2 to the power of 3, which means you're multiplying 2 by itself 3 times, and then you multiply 2 to the power of 5, which is 2 by itself 5 times, and what you end up having? You end up having 2 multiplied by itself 8 times, eh?
Oh yeah.
Yeah. So now we have 2 to the power of 8. Right? So what is the generalization for this rule? Remember we were coming up with generalization, right? So what is the generalization for this rule? If I have a number, so rule 1, if I have a number, any number. Alright, before we get to the rule, let's try one more. What if I had this? That's a multiplication sign, eh? What will this end up being?
You multiply the 2 by the 3 and then you add the indices.
You multiply the 2 by the 3, so 2 3s are 6. And then you add the indices 3 plus 4, 4, 5, 6, 7, right? 7, yeah?
Yeah.
Can you prove that? Let's see. Because this was 2 to the 3, right? So that's 2 being multiplied by itself 3 times. And then I'm multiplying that by 3 that is multiplied by itself 4 times. Right? So that will be 2 2s are 4 2s are 8 times 3 3s are 9 3s are 27. 27 by 3 is 81. So that gives me 8 multiplied by 81, which is 648. if I do 6 to the power of 7, 6 to the power of 7 is actually 279,936.
Oh.
So I guess this does not work. So at the end of the day, you cannot add indices here. You'll actually have to work it out and get your final answer. But you cannot add indices. Why can't we add indices? Because the base number is different, and
Yeah.
you could only add indices when the base number is the same. You understand? Right. So this is where we come to rule 1. Can you give me a generalized method? I'll do the first one, but you'll have to do the rest, okay? So the generalized form is, if I have two numbers, the base number has to be the same. So if this number is A, then this number has to be A. They have to be the same number, right? If this one is to a power of n, which could be anything, and this one is to a power of m, which could be anything, and this A could be anything as well, then the answer will be A to the power of n plus n. You understand that?
Yeah.
And I'm sure you knew this, right? Huh?
Yeah.
Right. But make sure that the base number, that base number being the same, is super duper 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 important. Cool?
Okay.
So what if I have 2 to the power of 5 divided by 2 to the power of 3? What do I do in this case?
Yeah, minus the indices.
Right, but prove it. Because 5 minus 3 is 2, so the answer is 2 to the power of 2, right? We know that, but prove it. This is the same as 2 to the power of 5 divided by 2 to the power of 3, right? Which is 2 multiplied by itself 5 times divided by 2 multiplied by itself 3 times, and
Yeah.
now we could see why the base numbers have to be the same, because if this was a 3, then we could not cancel out anything, eh?
No.
But because everything is 2's and it's all multiplied, it have no additions and thing, everything being multiplied and divided means that we could cancel out things from our side. So this 2 and this 2. So we have 1 being left in the denominator, and we are left with 2 squared. Right? So therefore, 2 to the 5th divided by 2 to the 3rd, which could be written as 2 to the 5th divided by 2 to the 3rd, is 2 to the 5 minus 3, which is 2 squared. You understand?
Yeah.
Right, what is the general rule for this one now?
A divided by A to the power n divided by 3m
To the power of m, and I'll just write it another way. I'll write it like this too. And the reason why I want to write it like that is because you all just seem to forget that this is another way to write a fraction. And And then when all you see a fraction, all you just tend to forget that a fraction actually means divide. Yeah? So is this meaning, these subtle meanings is what is making the difference. And what this is equal to?
A is n minus m.
N minus m. The one underneath is the one being minus. The one that is after the division sign, the divisor, is the one being minus. Right? So you understand this second rule here, right?
Yeah.
Very nice. What if I had okay, I guess I could probably fit one more. Maybe two more. Yeah, definitely two more. So what if I had this? 2 to the power of 2, and all of that is to the power of 3. Actually, you know what? It have one thing I had to show you again. Sorry about it. But up to here, you see this rule here, rule number 2? I forget one more thing to show you again, right? So, and then we're gonna move on to that next one. So we was doing this divide, 2 to the 5th divided by 2 to the 3rd, right? Now, what if I had 2 to the power of 3 divided by 2 to the 5th? What is going to be?
2 to the power of minus 2.
So we have here 2, according to the rule, 2 to the power of 3 minus 5, yeah? And that is 2 to the power of negative 2, right? Here is my question. I know that 2 to the power of 3, what does this mean? It means that I'm taking 2 and multiplying it by itself 3 times, and so if I have 2 to the power of negative 2, what does that negative mean? Am I taking 2 and multiplying it by itself negative 2 times?
What the number you get would be a negative?
Maybe not. What does this actually mean? And if I was to type 2 to the power of negative 2 in my calculator, the answer is a quarter. So that is not a negative number. So what actually happened in here? And I'll put the answer here, a quarter. Right? Well, let's prove it and see. Right? Let's prove it and see what this means. So I have 2 to the power of 3, right? So that's 2 multiplied by itself 3 times. And then I have divided by 2 to the power of 5. 2 multiplied by itself 5 times. And now things could start to cancel. Look what I have. I actually have 1 over here all over 2 squared. Seeing what's going on there?
Yeah.
Right. So therefore, 2 to the negative 2 is actually equal to 1 over 2 squared. In other words, when you have a number that has a negative power, that actually means that you have a fraction. Yeah?
Okay.
And now you could see how we end up getting the quarter. And yeah. So that is what a negative power means. A negative power, and this is the rule that plenty people just overlook when they're doing algebra. A negative power means that you actually have a fraction is what you're dealing with. You understand? So the generalization for this, rule number 3.
Absolutely.
Hey, what's up?
Actually,
Glad for you to join us, right? So the generalization for this is any number to a negative power is actually a fraction to that power. Right? Now, Caitlin, we were just doing some indices here, and we were talking about basic stuff and deriving some of these laws. Now, at the end of the day, the class is being recorded, so if you want to, when the class is over, you could always go back and watch and see what you missed out, right? But I'll just go it over real quick for you since you're reached, right? Caitlin?
okay.
So what we were actually saying is that 2 to the power of 3 means you're multiplying 2 by itself 3 times. Same thing with 2 to the power of 5. So what happens if you multiply 2 to the power of 3 multiplied by 2 to the power of 5? We can see here that we have 2 to the power of 3 and it's being multiplied by 2 to the power of 5, and that is just 2 multiplied by itself 8 times. So you just get 2 to the power of 8. So therefore 2 to the power of 3 times 2 to the power of 5, once the base is the same, you could just add the indices. 3 plus 5, which is 2 to the power of 8. Did you understand that, Caitlin?
Yeah.
Right? Now I'll give much more detailed explanations, right? Over here, we were explaining why if I have 2 to the power of 3 times 3 to the power of 4, I cannot add the indices here because these base numbers are not the same. So I'll end up getting some separate numbers. You understand?
Yeah.
You sure?
I think so.
Right. All I'm saying here is if the base numbers are not the same, you cannot add the indices. Right?
Okay.
And if you're iffy about it, you could always check the video. So the rule here is that the base numbers need to be the same if you're adding indices, right?
Alright.
Right. That is the rule here, right? So when you're dividing, you minus the indices, and we actually prove why. Because 2 to the power of 5 divided by 2 to the power of 3 is actually 2 to the power of 5 over 2 to the power of 3. And we put 2 times itself 5 times, 2 times itself 3 times, cross off all of the 2's because everything is being multiplied here. It have no additions and things. And we actually get 2 to the power of 2. So therefore, 2 to the power of 5 divided by 2 to the power of 3, you actually just minus the indices. Did you know this stuff from before, right?
A little bit, yeah.
But you understand what we're talking about here?
Yeah.
Alright, try to be on time for class next time, right? I know it wasn't your fault, right? But
I'm sorry.
Alright, no, that's fine. Is important though, that you don't miss anything, right? I really don't want you to miss none of this stuff. So go and check over the video when I upload it, right? So what we were talking about here is if I have 2 to the power of 5 divided by 2 to the power of 3. Because I'm dividing means that I minus the indices. So you understand up to there, right?
Yes.
And then we came up with the general rule that if I have the same number and I divide in, I just need to minus the indices. Nice?
Yes.
But then we did this thing here now where I have the same number and I'm dividing 2 to the power of 3 divided by 2 to the power of 5. And that is equal to 2 to the power of 3 minus 5, which is 2 to the power of negative 2. And my question here was, the question is, if I have 2 cubed, that is 2 by itself 3 times. So what happens when I have 2 to a negative number? Is that 2 multiplied by itself negative 2 times? So what does a negative indice actually mean? So in order to find out, we went here to prove it. We put 2 to the power of 3 and we divide it by 2 to the power of 5, and when we cancel it out we get 1 over 2 squared. So therefore we see in here that when you have an indice to a negative number, right, when your indice, when your power is negative, you are actually talking about a fraction. How you feel about this one?
Good. Okay.
You feel okay?
Yeah.
Alright, well just watch the video and you'll see how I explain the entire thing, right?
Okay.
So the rule here is that if you have a number to a negative power, it actually is a fraction, a positive fraction. You understand? So just because the power is a negative number doesn't mean that the number is negative. No, it just means that it's a fraction. You okay, Caitlin?
Yeah.
Alright, moving on. That is where we read so far, yes. So, Scotia, if I have 2 to the power of 2 and all of that is to the power of 3, what am I going to get?
Like 3 times 2. I do it 3 times?
Huh?
2 times 2 and do that 3 times?
Alright, so we have 2 squared and that is being multiplied 3 times, eh?
Yes.
So that is 2 squared, right, times 2 squared times 2 squared. Caitlin, you following so far? Sorry?
Yeah.
Alright. So 2 squared times 2 squared times 2 squared, when we expand it further, 2 times 2 and multiply by 2 times 2 multiply by 2 times 2, and this gives me what?
Four times 2 times 4.
No, not 4 times 4 times 4. 2 to the power of what? Remember, all of this is multiplied, eh? Multiplied, I have no additions here. They're all multiplied, right?
Yeah.
So what is that?
2 to the power of 6.
2 to the power of 6. So therefore, 2 squared, all cubed, is 2 to the power of 6. How do we get from there to there? What do you have to do to the indices?
Multiply them.
Yes. Right? So example 2. If I have 5 to the power of 2, all to the power of 4, that is what?
5 to the power 8.
5 to the power of 8. Right? That is, you multiply the indices. 5 to the power of 2 multiplied by 4, which is equal to 5 to the power of 8. You okay, Caitlin?
Yeah.
So what's the generalization for this one now, Scotia? So this is what, rule number 3,
4.
rule number 4. So rule number 4. What's the generalization for this? Any number to a power
In brackets.
to a different power is equal to
A multiply A and
to
N
the
multiply.
power of n multiplied by n, which could also be written as a to the power of n m. And
Yeah.
you okay, Scotia?
Mm-hmm.
You okay, Caitlin?
Yeah.
Alright, if you all say you're okay, no problemo. Right. So way to remember this one. Now I have one that I want. The rule number 5 is derived from this. So the next one we're going to do, you're going to have to remember this. But we're going to take a detour first to remember a couple of things. Remember. If I just have a number, just a random number, I just put a number there. What is automatically the power that is supposed to be here?
1.
Yes. So 3 to the power of 1 is 3. And? So the generalization, let me just make this a little smaller, a little too big. So the generalization, any number to the power of 1 is itself. And?
Yeah.
Can you prove this? Well, you could use any one of the other rules. For example, if I have a to the power of 1 times a to the power of 1, that is equal to a squared. And hello?
Yeah.
Right? So that is one way to show it. The fact that we have this a squared is a times a. We know a squared is a times a. Yeah? So we know that 3 squared is 3 times 3, which is really 3 to the power of 1 multiplied by 3 to the power of 1, which is really 3 to the power of 1 plus 1. And?
Yeah.
Caitlin, you okay so far?
Yeah.
You lost yet?
Not yet.
Alright. But this one, I want you to fight up with this one. Given that, we have a question here, right? Given that So given all of this, dot, 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 it just keeps going, right? Given that a to the 1 is a, and a squared is a times a, and a cubed is a times a times a, and a4 is a times. So given this information, prove that any number to the power of 0 is what? 1. So we all know this. We all should have learned this in SEA. That any number to the power of 0 is 1. It's not even the number, eh? No, it is literally 1. I want you guys to prove this for me. Any thoughts? Caitlin, are you able to prove this?
I'm gonna try.
Okay, how do you prove this?
Say for example, A1 divided by A1 is power.
That is a great thing. That's exactly a great proof. Yes, exactly, right? Sorry that I'll give you 2 minutes. I should not give her 2 minutes. But yes, it's true. A to the power of 1 divided by a to the power of 1. We know anything divided by itself is 1. But this is actually a to the power of 1 minus 1 according to the rule, which is a to the power of 0. And anything divided by itself is 1. Yeah? So therefore, anything to the power of 0 is 1. Another way is we could see it right here. If I take a to the power of 4 and I divide that by a, I'll get a to the power of 3. If I divide that by a, I'll get a to the power of 2. If I divide that by a, I'll get a to the power of 1. And if I divide that by a, you'll end up with a to the power of 0, which is 1. Right? And look at it. If I have a to the power of 0 is 1, right? And I divide that by a, what I'll have now is a to the power of negative 1, which is 1 over a. Yeah? So we have like this indices number line taking place now. Yeah? So we have a to the power of 0, a to the power of 1, a to the power of 2, a to the power of 3 on this side. And then on this side, a to the power of negative 1, which is 1 over a to the power of negative 2, which is 1 over a squared, a to the power of negative 3, which is 1 over a cube, going down that side. And we already saw how anything to a negative power is actually a fraction. That was rule number 4 or rule number 3 or something. That was one of the rules we just did. So how are you all feeling about this stuff? Did you guys know all of this already? Let's just recap. First, we did rule number 1, which is that if you're multiplying two of the same numbers, you add your indices. Rule number 2, if you are dividing two of the same numbers, you minus the indices. Rule number 3, if we have a negative indices, that actually means that we have a fraction. And rule number 4 is if we have a number to a power and all of that is put to another power, you actually multiply the powers. Right? And then here we remembered two things. We remembered that anything to the power of 1 is itself, and anything to the power of 0 is 1. So everybody okay so far with all of this stuff here?
Yeah.
You sure? Alright. Caitlin, you okay?
Yes.
Alright. So let me just do one last one here. Now we're going early today, right? Today is going to be an early day. because I am exhausted. If I have the square root of 9, what does this mean? Nobody can tell me what this means? If you had to explain it to a 5-year-old, right? If I was 5 years old and I asked, Caitlin, what does this mean? The square root of 9. What does that mean?
A number multiplied by itself will give you that.
Right. So the square root is actually a question, isn't it?
Yeah.
The question is, what number when multiplied by itself gives 9? And we know the answer to that is 3. Yeah? 3 times 3 gives 9. So therefore, the square root of 9 equals 3. Yeah? So that means that 3 times 3 equals 9, which means that 3 squared equals 9. And? Right. That means that I could take this 9. This 9 is 3 squared, and so therefore 9 is equal to 3 squared. And
Yeah.
so when I square both sides, that square root sign disappears. And so therefore, instead of having the square root of 9, I could have the square root of 3 squared. And
Yeah.
So the square root of 3 squared we know is 3. And
Yeah.
so it's almost like if this square root sign just cancel off with the 2, and to give you 1. And it's almost like that, right? So let me ask you something. If I have 2 and I want to... Alright, just now, before we get to that question. So we have the square root here of this entire number, and yeah?
Yeah.
This whole number here, 3 squared, the whole thing is being square rooted, right? So I could say that is 3 squared in brackets to some power. And that gives me 3 to the power of 1. Didn't we see here, didn't we see that when you have a number in a bracket and all of that, or the whole number, a number to a power, the whole thing in brackets to another power, what do you do with the 2 power?
Yeah, multiply.
Right. So therefore, 2 multiplied by some number is supposed to end up giving me 1. And so what is the number? 2 multiplied by what is going to give me 1?
Uh-huh.
Yes, thank you. Caitlin, you're supposed to answer that question, eh? Alright. You there, Caitlin?
Yeah, yes.
Alright. So 2 multiplied by 1/2 is the only thing that'll give me 1. So therefore, the square root of 3 squared Remember, this entire 3 squared is under the square root. That is actually the same as saying 3 squared all to the power of a half. And that will give me 3 to the power of 1. So therefore, rule number what? What rule we on now?
Five?
This is going to be rule number 5?
Sure.
Alright. So rule number 5 is when you have the square root of a number, that actually means that that number is to the power of a half. Now, did you guys know all of these rules before?
Most of them, yeah.
Which ones did you not know?
Well, probably not. No, probably just didn't remember.
Alright, now these things, especially indices, real important in algebra, because we're going to get a lot of algebra that involves indices. Now, these are not all of the rules. When we do algebra, we're going to start algebra very soon. When we do algebra, we're actually going to have to do over the laws of indices. And if we have 5 laws here, 1, 2, 3, 4, 5. And it probably have about 3 more that we'll need to add on. Nice? But we're just keeping it simple and basic right now. Everybody understands this, right?
Yeah.
Alright, now let me just see something here. So, 5 minutes. You get it done. Actually, I'll finish in 2. As soon as you're done, just 1 minute. So, obviously, when you're multiplying, you have to add your indices. So, 6 plus what gives 17?
11.
11. Right. Over here is the same thing. So 6 plus what gives me 11? 5. Right. Over here, dividing. So you're minusing the indices. So this is 2, and
Yeah.
6 minus 2 will give me 4. Right. Caitlin, you okay with them 3 so far?
Yeah.
You get them correct?
Yeah.
Alright, good job. Over here you have to multiply the indices. So 6 times 3 will give me 18. Over here I have to multiply the indices. So where's this 95? So 95. So 95 divided by 19 is what? 5. So this here is going to be 5, right? Over here, you have to is a divide sign, so you have to minus the indices. So 16 minus what will give me 7?
9.
9. And over here, if you multiply these two, you'll get 40. So 5 times 8 will give me 40. And over here, if you minus these two, you'll get 1. And so 13 minus 12 will give you 1. So, and everybody got all correct?
Yeah.
Caitlin?
No, I didn't get all correct.
How much you get wrong?
3.
You get 3 wrong?
Yeah.
Which 3?
The 2 with brackets and an F.
These 2 with brackets here?
Yeah.
Why you get them wrong? What did you do?
I had take away the 95 from 19. Right.
But you understand what we did here?
Yeah.
Didn't we say that when you have the brackets and powers, you multiply the powers?
Yeah.
Right. So 19 multiplied by what will give me 95? Well, all you really need to do is you need to divide the 95 by 19 and you'll get 5. You understand?
Yeah.
So you understand what you did wrong and what is the correct thing to do?
Yeah, I understand what I did wrong.
So is all these 3 with the brackets you got wrong?
Yeah.
So that means that is the one rule that you did not really know, right? Okay. Next. So that's all for indices so far. That's all that we'll be doing for indices so far. Okay. Now we're going to move on to another easy topic. That's related to indices. And this one is called anybody did scientific notation before? It's also known as standard form. Okay? Everybody cool with this, right?
Yeah.
Alright, let's go. If I have 2 multiply by 10, what is that?
20.
20. If I have 2 multiply by 10 squared, what is that?
20 squared.
20. You're sure? Because this is 2 to the power of 1. And what you're saying is I could multiply this by this? Is that what you're saying? Didn't we say you can't really do anything with the bases? Be very careful, please. No, you cannot. 2 multiplied by 10 squared is what? What's the answer? Caitlin? Are you overthinking, man? What is 10 squared?
That'll be 40.
Huh?
That'll be 40.
2 multiplied by 10 squared. What is 10 squared? Just answer that question. What is 10 squared?
100.
Right. So wait, is you telling us 40?
Yeah, I made a mistake.
This is 2 multiplied by 100. And
Yeah.
what's the answer?
20.
Caitlin, you following?
Yeah.
Because you are characteristically quiet. What is 2 multiplied by 10 cubed? Caitlin,
Yeah.
that is what the answer.
2000.
2000. How you get that?
Because 10 cubed is 1,000.
Right. So 10 cubed is 1,000, so 2,000. What is 2 multiplied by 10 to the 4?
$20.
20,000. So you notice obviously the numbers are getting bigger. Yeah. You notice that this here have 1 0, so the answer have 1 0. You notice this here, the squared means it's 2 0. So the answer is 2 0. This cube means we're dealing with 3 zeros. This 4 means we're dealing with 4 zeros. Everybody okay so far?
Yeah.
Right. But what I actually want you to look at is the decimal place, is what I want you to look at. Because this 2, the decimal place is over here, and 2.0, and
Yeah.
right. So what we actually have is we actually have 2.0 times 10 squared. So that means that that decimal place have to move 2 spaces, and 2.0, but that decimal place have to move 2 spaces to give me the 200. Is everybody okay with this?
Yeah.
Caitlin?
Yeah.
So in this case, I have 2.0 times 10 to the 3. So how many decimal spaces does the point have to move?
3.
3. You okay with that, Caitlin?
Yeah.
You know, Caitlin, when I ask a question, it's not just for you to wait for Scotia to answer it, yeah? Alright? So, Caitlin, you answer this question for me. If it is that I have 2.0 multiplied by 10 to the 3, how many decimal spaces is this going to move?
3.
Right, 2.0, and you're moving 3 decimal places. 3. And another 2,000, right? So what if I have 2 multiplied by 10 to the 6? What will that give me? How many zeros will it have?
6.
How many spaces do I have to move the decimal, please?
6.
So 2.0, 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6. 2 million. What if I had 2.75 multiplied by 10 to the 6? What will I have to do?
You still move the point system.
That's all I have to do. Caitlin? Alright, you know what? From now on, I'm just going to ask Caitlin because Caitlin's staying quiet, right? Caitlin, what does I have to do here?
Move the decimal point 6 times.
Okay, so I have 2.75 and by 10 to the 6, so I just go in 6 times. 1, 2, 3, 4, 5, 6. So I add 0, 0, 0, 0. So I end up with 2,750,000 is the answer. What if I have 2.75 by 10 to the 23? Caitlin, what do I have to do there?
Move the decimal point 23 times.
Right, and I'm not going to do that because that number is going to be really, really long, right? Would you like me to do it, Caitlin?
No.
2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Put that, comma there, comma there, comma there, comma there, comma there. I don't even know what number that is. Don't even know what number that is. This here is called standard form or scientific notation, right? Why do we use scientific notation? Well, imagine if you were measuring something, or if you had to do a very advanced calculation. And imagine this number was involved in this life or death calculation. So imagine this number is involved in a life or death calculation. You have to get it right. Imagine you writing this number and you accidentally leave out a 0. Then guess what's going to happen? You'll get it wrong and everybody dead. So, when we have very, very big numbers, instead of writing it out like this, we can write it out in standard form. Does everybody understand what standard form is?
To make a big number easier to read.
Pretty much, that is it. Not only easier to read, but you can easily do calculations. Imagine you have a whole page worth of calculations that you're trying to do, and you had to keep writing over this number. That's a hard thing to do when you can easily get it wrong if you miss out a 0. So instead of writing over this number, you could always just write it in standard form, and it'll make your calculations a lot easier to do. You don't find so?
Yeah.
So this is the thing about standard form. Very large numbers could be written in standard form, right? Or and this, I go hear silence now. Watch how quiet all you're gonna stay for this one, right? And remember all your laws of indices. So remember we had 2 multiplied by 10, and that was 10 to the power of 1, right? And that gives me 20, ain't? You understand?
Yeah.
Yeah. Caitlin?
I understand.
Alright. And we saw that you moved the decimal place 1 space in this case, right? What if I have 2 multiplied by 10 to the 0? What's that going to give me?
2.
Yeah. What is 10 to the 0, Caitlin?
2.
Well, yeah, 10 to the 0 is 1. So 2 multiplied by 1, that is just 2. Right? What if I had 2 multiplied by 10 to the negative 1? We just said that if you have a number to a negative, what does that mean? A number to a negative power. What does that mean? A fraction. So what is the fraction here? What is this fraction? This fraction is what?
1/10.
1 over 10. So where's 2 multiplied by 1 over 10? Yeah, which is also 2. Where's 2 divided by 10? The answer I wanted was 0.2. And
Yeah.
everybody understand, Caitlin? You okay?
Yeah.
I want you to notice what's going on with the decimal space. This is the point. Well, it's literally the point. Yeah. So we notice that. What about 2 multiplied by 10 to the negative 2? What's that gonna be?
One over 10 to the power 3.
Where's the answer?
One over 100.
I mean the final answer. What is 2 times 10 to the negative 2?
0.06.
Caitlin, what is the final answer? What is 10 to the power of negative 2 as a fraction? Right. So this is 2 divided by 100, and
Yeah.
which is what?
0.02.
0.2. The questions that I'm asking Caitlin are not hard questions. They're easy questions. And you are overthinking. So please stop overthinking and just think simply. Right? So let's go again. Caitlin, 2 multiplied by 10 to the negative 3 was the final answer here.
0.002.
Right. So I want you to look at this now. You saw here that when this power is a positive, that the decimal space moves that way. Yeah? We saw here that when the power is a negative, that means you're multiplying by a fraction, which means that your final answer is going to be smaller and smaller and smaller. So we could see that the decimal space is moving that way. So in this case here, I had 2.0 and I'm multiplying it by 10 to the negative 1. So that means that I'm going to move, because it's negative, means it's a fraction. That means that the decimal space is going to move this way instead. And how much spaces is it going to move by? It is going to move by 1 space. 0.2. 0.2. You understand that, Caitlin?
Yeah.
Scotia, you okay?
Yeah.
Let me know if I don't understand anything, eh? Right. Same thing here. This is 2 by 10 to the negative 2. So 2.0 and by 10 to the negative 2. Negative means that the decimal space is going to be moving here. And by how much decimal spaces is it going to move, Caitlin?
See?
Yes, easy questions, Caitlin. Easy questions, right? So it's going to move, because this here is a 2, it's negative, so that means the decimal space is moving that way. And it's going to move that way by 2 spaces. So now we end up with 0.02. So you could tell that if I had 2 by 10 to the negative 23, that's going to be what? 0.23 zeros (21, 22 zeros and a 2). And you can see that? Caitlin, you understand how I got that?
Yeah.
You sure?
Yeah.
So the point here is that when I have very, very small numbers, I can also represent that in standard form. You understand?
Yeah.
Any questions?
No.
Did you guys write this down?
Yeah.
Caitlin?
Yeah.
Let me see how good Ollie is. Write each one of these in scientific notation. Now, it just have a rule for scientific notation, right? Let me just do the rule first before. So scientific notation or standard form is always written in the form and a generalized form. A point, well, A A point something, right? So it's A, I don't want to put the decimal. A times 10 to the n, right? We could see here that n could be positive or negative. And we always want this to be a single digit. So I don't want to see 23 by 10 to the 5. This is wrong. This is not standard form. What could we do to change this to standard form? Write it as what? I could write it as 2.3 by 10 to the 4. No, it's not 4. It's 2.3 by 10 to the what? 6. 6. 1. Yes. 6. That's one. Yeah. 1, 2, 3, 4, 5. And then this will be 1, 2, 3, 4, 5, 6. Yes. By 10 to the 6. So this is correct. Caitlin, you understand this part?
Yeah.
That does sound like a very good year. Right? So the point is that this number has to be A has to be less than 10 and it has to be greater than 0. You notice I didn't put equal signs, yeah? So that means it cannot actually be 0. It cannot actually be 10. It has to be more than 0, whether it's 0.1 or 0.001, right? It had to be more than 0. I want one number before the decimal point. Actually, no. You know what? No. It should be 1. Yes. So I can have 1.0. I can't have 0.1. Right? I can't have 0.1. I want 1.0. Right? So, I know it might seem a little confusing, but before I confuse you more, let's see if we could try some of these. Write each number in scientific notation. So what do you think this would be in scientific notation? What would the A number be? It will be 6.0, right?
Yeah.
By 10 to the what? Well, all you had to do is count from the decimal place here. 1, 2, 3, 4, 5, 6. Yeah? So that's that. So by 10 to, but would it be 6.0 by 10 to the 6?
be negative 6.
Thank you, Caitlin. Why?
Because,
From here to here, this number is smaller than 6, isn't it?
yeah.
Yeah, this number is a really small number. If it is that I had 6.0 by 10 to the 6, that is actually 6 with 6 zeros, eh?
Yeah.
6 million. So you had to be careful. Right? It's actually negative 6 because you want this 6 here to get smaller to become that number. You understand, Scotia?
Yeah.
All right. So give me this one now. What's this one gonna be? Quick.
5.4. Seven.
So if you put the point here, then the point will have to move 1, 2, 3, 4, 5, 6.
Uh,
Huh?
yeah.
So by 10 to the 6. And that will give you that. You understand, Caitlin?
Yeah.
It's actually really easy. You just kind of just follow your decimal spaces. If you're negative, you're going in this direction, you're getting smaller. If you're positive, you're going this direction, you're getting larger. Right? So, where's 60 in standard form? Quick.
6 times 10.
6.0 times 10 to the power of 1. Excellent. Caitlin, number 4.
9 multiplied by 10 to the power of 4, negative 4.
So if I had 9.0 and at times negative 4, that means that I'm moving the decimal space 4 spaces. 1, 2, 3, 4. So I'm going to end up with 0009. So come again. An easy way to do it is to just put the decimal place behind the 9. Eh? And then just count backward. 1, 2, 3. And Caitlin?
Yeah.
That is an easy way to do it. Are you seeing the easy way?
Yeah.
Right. So Caitlin, give me this one.
2.0 multiplied by 10 to negative 7.
So if I put the point here, 1, 2, 3, 4, 5, 6, 7, negative 7. Excellent job. Right. Where's this in standard form? A little trick question here for you, because this already in the form, so the decimal place don't have to move, eh?
Yeah.
So what is going to be 6.7 times 10 to the 0, and
Oh, yeah.
you understand that, Caitlin?
Yeah.
10 to the 0 is 1, so this is that number in standard form. What is this number in standard form? Remember, that's 71. The point is over here right now. That is 71.0. So what is that number?
71,000.
Huh?
71,000.
Yeah, but I want this. This is not in standard form. Why is this not in standard form?
It's over 10.
What over 10? Oh yeah,
It's not single digit.
this number is not a single digit, right? So I want 7.1, eh? So
Yeah.
that's gonna be 7.1 by 10 to the what? Caitlin.
Negative 1.
7.1 by 10 to the negative 1 means that I'm going to take this point and move it here, and that is 0.71. That is not what we want.
Oh.
C1.
Huh?
C 10 to the power 1.
10 to the power what?
1.
Alright. 7.1 by 10 to the power of 1 is 71. Yeah, that is 71 there, but that does not express this number. What is this number? This number is 71,000, and
Yeah.
so imagine the point is over here, and you bring back the point 1, 2, 3, but then you bring it back again 4, and so this is actually 7.1 by 10 to the 4 is the same as 71 by 10 to the 3, which is the same as 710 by 10 to the 2, which is the same as 7100 by 10 to the 1. And you understand?
Yeah.
Caitlin, how you feel about this one?
That's another before.
You want me to explain it again?
Yes, please.
Alright. So we have here 71 times 10 to the 3. Right? It is not in standard form. We know standard form we want 7.1 by 10 to the something. Yeah? We have to express this number in standard form. So we could say, okay, 71 by 10 to the 3 is 71,000. Right? Because remember, that is really 71.0, and you move 1, 2, 3, so you'll get 71,000. You're okay up to there?
Yeah.
Alright. So from the 71,000, I know I want to end up with 7.1. So from the 71,000 now, I could take this point and move it back 1, 2, 3, 4. And so 7.1 times 10 to the 4 will give me this. And
Yeah.
so that means that these two are equal. And
Oh.
you get what I'm saying?
Yeah.
Right? If I want, I could bring the point back again. 0.71 times 10 to the 5 will give me this. And
Yeah.
right? But at the end of the day, this is not standard form. How you feel about it now, Caitlin?
Good.
Alright. Where's this in standard form?
2 times 10 to the power of 6.
Okay, if I have the point there, 1, 2, 3, 4, 5, 6. Okay, good job. And can we just do? Okay, let me see. Alright, well, so we did 8. Yeah, and that, I think you all got the point. Did you guys write this down?
Yeah.
Caitlin, you wrote these down?
Yeah.
You sure? All of them?
Yeah.
Alright. Okay. So we have numbers here that you can write into standard form. And then we have the standard form, right? Each number in standard notation. Oh no, this is not in standard notation. Yeah, this is still not in standard notation. Well, some of them are. This one isn't. And that one is. Right? Each number in standard notation. This one already is. A couple of them already are in standard notation. Oh, but you had to have this decimal place, yeah? You had to have, so for example, this in standard notation would be 2.0 times 10 to the negative 1. Yeah? Just now. That is not the... wait. Right, I thought that. Write each number in standard notation. That's actually wrong question. The question itself is wrong. Because look, you have here, write each number in scientific notation. Right. And they have here, so this is scientific notation, also called standard form. And standard notation now, it just means write the number normal. That is what I mean by this one. Right? So, let me take this first one. What is the normal number?
Zero point zero nine.
0.09. Caitlin, you understand that?
Yeah.
Caitlin, give me this one.
0.2.
Very good. Yeah, I think you all understand it now. That is it. So today we had quite a productive class. Today we did indices, and today we did scientific notation.